Hi everyone. Okay, so this is Jacob's Algebra and we're on Chapter 7, Lesson 1, and we're working on simultaneous equations. And in the problem set, these are the problems that we needed some help with. So, number 4 in the set, the directions were tell whether or not each of the following ordered pairs is a solution of the simultaneous equations given. Remember that to be a solution, the ordered pair must make both equations true. So basically what we're doing is they're giving us the numbers to plug into the equations. And then if you'll notice in red, in a coordinate, x is always first, so our red number is 0, and our y number is -3. So we're simply going to plug those in to where x and y are and solve for the equation. So x is 0. Minus 2 times y, which is a -3, equals 6. So we know that a -2 times a negative. So a negative times a negative, we're looking at this right here. A negative times a negative is a positive. So 2 times 3 then is 6. Oops. And 6 equals 6. We'll go over to this equation. Y, which in our coordinate is -3, so we'll plug that in. -3 equals 1/2 times x, and x is 0 minus 3. Okay, let's just bring the numbers down that are on the left-hand side of the equal sign. We don't have anything to do with them right now. We know that 0 times any number is 0, so we don't have anything to do with that fraction. So we just put 1/2 times 0 is 0 minus 3. So -3 equals a -3. Check, check. All right, the next problem was 4i. Our x is red and our y coordinate is green, -8. So we simply take our -10 and plug it in where the x is in the equation, and our -8 where the y is. So -10 minus 2 times a -8 equals 6. Okay. All right, let's remember our order of operations. Please excuse my dear Aunt Sally. Parentheticals, exponents, multiplication, division, addition, subtraction. Well, there's only one number inside a parenthetical, so the first operation we need to do, we have no exponents, so we need to multiply. So, notice that we're multiplying a negative times a negative, which means anytime we multiply a negative times a negative, we always get a positive. So we'll go ahead and put that there. And 2 times 8 then is 16. That was really bad. Let's see if I can write that better. Okay. And then we bring down our -10 equals 6. And we know that 16 plus a -10 is really subtraction, 16 minus 10, which leaves us with 6. So that so far is true. Okay, so let's work with the next one. Y equals 1/2 or 1/2 times x minus 3. So let's go ahead and plug in our y. Let's put our 1/2. Now, it's 1/2 times our x, which is -10, and we can write it -10 over 1 minus 3. Okay, So let's attack this. This is 1/2 times negative 10 over 1. So the opposite operation of multiplication is division. So 1 divided into 1 cancels each other out. So we are left with negative 10, simplifying this, over 2. Now, 2 is a positive, and so we know a positive divided by a negative, or a negative divided by a positive, always leaves us with a negative. So 2 goes into 10 5 times, or 5 over 1. So 5, whoops, grab the right pen here, 5, and then don't forget we have that negative 3, or minus 3, 5 minus 3, and we'll bring down our y, negative 8. Now, notice that we need to put our negative sign in there because we have opposite positives and negatives we're dividing, which means our answer will equal a negative, and in this case it's a negative 5. So negative 5 minus 3 is really, you can't do it this way, it's easier to do negative 5 plus a negative 3, which gives us a negative 8. And we have a negative 8 on this side of the equation. So it is true, both sides of the equation are the equal. So the question is, do the ordered pairs of the simultaneous equations, are they true? Well, if we end up with both sides being equal, then it's true. Okay, in number 15, it's the same directions. We're to determine whether the ordered pairs has a solution that is true. So in order for it to be a solution, it has to be true. So x is in red, the coordinate up there 5, and y is in green 0. So all we're going to do is, like we've been doing, is plug those numbers in where they belong. So 2 times 5 minus 0 equals 10. 2 times 5 is 10, minus nothing is 10, and that leaves us with 10 on the left side and 10 on the right side. So far they're true. But let's go to the other equation and make sure. All right, x is 5, and then we have 1/2 times y, and y is 0. And we know any number times itself is 0. So I'll go ahead and bring down my 5 and my equals. I know this is 0, so it leaves me with just 5. So 5 is equal to 5. So this statement is, these coordinate pairs are true. Okay, we had two others in 15, H and I, but now that I've shown you G previously, I want you to go back and work H and I, and you have your solutions, and I want you to make sure you can do it now that I've showed you how to plug those in. Let's look at the next problem some of us missed, which was number 21. Number 21 says, solve the following simultaneous equations. Show your steps and check your answers. Okay, so I've put the number set that belongs with x in red and the number set that belongs with y in green. Our top equation is 5x plus 3y equals 9. And our bottom is 5x minus 3y equals 21. Okay, so what we're left asking ourselves is, in order to get this down to one variable, we have to get rid of one variable because we can't solve these equations with two variables. The way we do that is we're trying to eliminate or cancel out one of the variables. Notice that plus 3y and minus 3y are given. And basically what that's telling us is if we add both equations together, then we cancel out the plus 3 and the minus 3. Because if we look on the number line here, and we'll make this 0, and each line to the right will be worth 1, then we know that plus 3 puts us here, and minus 3, we start from 0 and count to the left. 1, 2, 3, here. So, if we start at plus 3 and we add a negative 3, that means that we're jumping backwards 3 steps on the number line. 1, 2, 3. It lands us at 0. If we start at the negative 3 and add 3 to it, that means we've got to move to the right 3 steps. 1 in the positive direction, 3. And we landed 0. That's why we know when we add plus 3 and negative 3 together, plus 3y and negative 3y together, we are canceling out y. So let's go ahead and add that, and we'll cancel these out. And you can do it the other way. You could have done subtraction, because if you look at 5x minus 5x will do the same thing. It will get you at 0. But I chose to eliminate y first by just adding these two equations together. So 5x plus 5x gives me 10x. Bring down my equal. And 21 plus 9 gives me 30. So x is not by itself yet, and in order to solve for x, it has to be all by itself on one side of the equation. So in order to do that, it says 10 times x. In order to get rid of the 10, we have to do the opposite operation of multiplication, which is division. So we'll divide by 10. That cancels it out, and we'll divide by 10. So now x, it's an unstated 1 times x, and we know 1 times any number that we plug in there is going to leave us with that number. So we're good with just saying x, and we know that 10 goes into 30 3 times, so we now have solved for x, and I'm going to put it up here in a coordinate. X is 3. So now we need to solve for y. What we do is simply, remember, we can solve for one variable. So what we need to do is pick one of these equations and plug in x into our equation to solve for y. So let's just do the top. 5 times x, which we say is 3, plus 3 times y equals 9. 5 times 3 then is 15, plus 3 times y equals 9. Let's go ahead and move 15 over to the other side, or eliminate it on this side. So we have a positive 15, so we will subtract 15 to this side and subtract 15 to that side. Okay, so now we're left with, let's go down one. 3y equals, and 15 minus 9, when we're subtracting, the biggest number is what will hold the sign, either positive or negative. So we know our answer is going to end up negative. And 9 plus 6 is 15, so 15 minus 9 is 6. So we have a negative 6. Well, we're not done yet because y is not hanging out by itself, so we haven't solved for it yet. So in order to get rid of 3 times y, in order to get rid of the 3, we do the opposite operation. We divide. And what we do to one side, we have to do to the other. This cancels out, or leaves us with 1. Y equals 3 goes into 6, 2, don't forget our negative, and we have a negative 2 for y. Okay, well, now we got to check and see if our coordinates are correct. In order for them to be correct, that's what we've been doing in the other problems, if we have to verify if they're true. If this is a true coordinate, meaning that this, let me get my little arrow here. This is a linear equation, which means it'll form a line on a graph. And this is a linear equation, and it means it'll form a line on a graph. And what this coordinate tells us, if it's true, is that is where the two lines will intersect at 3 and a negative 2. So real quick, let's just see what that looks like on a graph. Oops, that wasn't very straight. All right, so if we make a coordinate graph, and let's remember that the quadrant number 1, or the upper left quadrant, is telling us that we have x will be a negative because we're going to the left on the x-axis, and that y will be a positive. And we know in the next quadrant on the upper right that x, we are going to the right or positively, and y, we are going above the x, which is a positive move. Whoops. So we have a positive and a positive. The next quadrant on the lower left, we know we're going from 0 to the left or negatively or backwards on x. So we know x would be a negative. And that we're going down on the y-axis from 0, so we're going negative. And then the last quadrant, we know that x, we're going to the right, we're moving forward, if you will, we're going in the positive direction. And y, we're still down here in the negative. So if we look at our coordinates, we can already guess that which quadrant are we going to be in. We're going to be in the quadrant where we go positively across on x and down in y. So we are going to be in this bottom right quadrant. All right, well, let's map that out. So from 0, 3 is x, we go over 3, 1, 2, 3. If I can get it to draw. It's not being very nice to me right now. Okay, we go 3, and then we go down negative 2 steps. So our point is going to be right there. Okay, so we know that those two equations up there are going to intersect at this point. Okay, and we don't know exactly, but just hypothetically, we might have one like this, and we might have one like this. But we know that the coordinate, if this is true, what we have found will be where they meet at 3 and negative 2. And actually, this is what we will manipulate in 7.4, but I wanted you to see why you're trying to solve for these things. All right, So let's get rid of this and let's do the last couple steps is to see if what we found is a true statement, if that's where they truly intersect. And again, how we do that is we plug in the coordinates like we've been doing. So x is 3 and y is -2. So let's start with the top equation. 5 times x, or 3, plus 3 times y, or -2, is equal to 9. Okay, simple math problems for us. 5 times 3 is 15, plus 3 times a -2. So a positive times a negative is always a negative, and 2 times 3 is 6. So -6 equals 9, and 15 minus 6 basically is what that is, or plus a -6 is 9. So 9 is equal to 9. So we can check this one off. So far, our coordinates are true, that's where the two lines are going to intersect. But let's check, just to be sure and to be thorough, let's check the second equation. So we start off with 5 again. And 5 times x, x is 3, minus 3 times y, y is a -2, is equal to 21. Okay? We know 5 times 3 is 15. Now, a negative times a negative, when you multiply two negatives together, you always get a positive. So, a positive and 2 times 3 is 6, equal to 21. And 15 times 6 then is 21, which means both sides of the equation are the same, they're equal, which means that our coordinates 3 and -2 are where both lines are going to intersect, so they are true. We got the correct answer. The last problem we struggled with is number 22, and it's in the same direction set where we are trying to find the coordinates. So we are trying to solve for one of the variables. So in order to do that, we have to get rid of the other one or cancel it out. Now, they tried to trick us a little bit. Instead of going ahead and putting x under x and y under y, they've reversed the order. Okay, well that's an easy fix. We need y and x in both equations to be underneath each other. So, just to make life easier. So what I'm going to do is I'm going to bring down the top equation. X minus y equals 11. And then this equation, I'm going to reverse. So plus x, so a positive x, and this is a positive y, so plus y equals 5. Okay, now we can look at this equation and see what we need to do. We need to eliminate one of the variables. Well, to eliminate x, we have a positive and a positive. So we'd have to make one of those negative by subtraction, and then it would cancel it out. But we already have a negative y and a negative 1y and a positive 1y, if you will. And so it's pretty much set up for us to cancel out y if we add both equations together. So we are going to add 1x, basically that's an unstated 1. 1x plus 1x is 2x. And then negative 1y plus a positive 1y cancels out y. And 11 plus 5 is 16. Now we're not done, because in order to solve for x, x has to be all by itself. So we have 2 times x equals 16. The opposite operation of multiplication is division. So if we divide this side by 2, we get 2 over 2, or 1. So we are eliminating that. And what we do to this side, we've got to do to that side. So we'll divide that side by 2. So x is equal to 8. Okay, so we'll go up here and build our coordinate. We know that x is 8. So now all we need to do is solve for y. Well, we could use either equation and just plug x into it, so we're left with one variable. So, doesn't really matter which one we do. I'm going to go, just pick one randomly. I'm going to go with the first. No, I'll go with the second. So, y we don't know. So y plus x, which is 8, equals 5. Okay. We've got to get y by itself, so we need to subtract the 8 from this side and subtract the 8 from that side. So these cross out, so y equals, 8's the bigger number, and so it will be a negative 3. Okay, so let's go ahead. We have solved for y, and we will put it up in our coordinate. Okay, so now the next step is to verify that the coordinates are true. In other words, that is where this line and this line will intersect. Okay? So, all we have to do is what we did initially, which is take our x value of 8, plug it into the equations, and our y value of negative 3, and see how we did. So, x minus y, 8 minus a negative 3 equals 11. Okay, well this is basically saying 8 minus, or a negative 1, times a negative 3. And we know a negative times a negative is a positive. And we know 1 times 3 is 3. Bring down our 8 in our other side of the equation. And we know that 8 plus 3 is 11. So far, our coordinates are accurate. Let's plug in the last one. Y plus x equals 5. So y is a negative 3 plus x, which is 8, equals 5. We know when we are adding, it's the number that's the biggest that will tell us whether it's a positive or a negative answer. This one is a positive, so our answer will be positive. And we know that 8 plus a negative 3 does indeed equal 5, and 5 is equal to 5. So we know our coordinates, our two lines, will intersect on a graph at 8 and negative 3. And just to remind you that if you have a graph, 8 tells us how far over the x-axis we're going to go, and it's a positive, and then there's negative 3, so we're going over positive on x and down negative on y, so we know over here somewhere at the negative 3 and 8, which I can't draw for exact with the lines, but it will be down in this quadrant here. Okay, well, I hope that helped to answer the questions you had on 7.1, and call me if you have any questions.